Hi, I'm Megan Fitzpatrick, and I'm going to talk to you about MCMC, which is Monte Carlo Markov chain. So you just learned about maximum likelihood, which is an excellent method to find a single point estimate for your model parameters. But perhaps you recognize there is uncertainty across multiple parameters, and you want to describe that range of uncertainty when you're trying to find your estimate for beta, when you're trying to fit to your data. So MCMC can help you there. When you have multiple varying parameters, the likelihood space for beta gets pretty complicated. To understand how we were going with this, first, let's think about the shape of the likelihood function when you are only varying one parameter, let's say beta. It may follow a unimodal distribution, and it may be pretty straightforward to maximize right about here. But then let's think about how varying a single parameter, let's call it gamma, in concert with beta could change this function. You could imagine it as a hill in 3D, where the likelihood is maximized at a particular combination of beta and gamma, right here in this red zone. You can imagine this is a topographical heat map of the likelihood, with red at the highest values, moving out to green at lower values. In your 2D space for beta, you were only seeing one single slice of gamma. Let's call it gamma 1. And the perspective might be different if you were at gamma 2. You can see that the location of the peak shifts and the height of the peak shifts. That if you're looking at the slice for gamma 2, you're in a different unimodal space altogether when you're considering across beta. So as you add another parameter to that, for instance, let's say sigma, that hill moves and changes shape. So this here on the right is what the same parameter space might look like at a different value for sigma. So here at sigma 1 is the space we were just looking at. Sigma 2, it's changed the location of the peak, the shape, and the relationship to the two other parameters, beta and gamma. And if you wanted to change yet another parameter, then I have run out of visualization space for you. So MCMC is a process that explores this multidimensional space. The first MC stands for Monte Carlo, which indicates that the search process incorporates randomness, right? Monte Carlo is a famous city for casinos and gambling. So it means that randomness and chance is incorporated into your process. The second MC is for Markov chain, which means that what happens at every step is conditional on what came before. So together, the MCMC process is one where each step uses parameter steps, jumps of random size and direction to move around the likelihood space, the Monte Carlo part, and where every jump starts with the parameter set that you had before, which is the Markov chain part. So you can imagine yourself, or rather the computer, as a tiny surveyor who's moving around this topographical space, trying to find the peak and recording where he's been in the process. So if you look at these arrows, you can see that they're moving in different directions each time, and they're of different lengths. They're jumping around the parameter space. And a key element for all of this jumping is that not every jump is considered successful. When the parameters shift, you might find yourself in a better or a worse likelihood space. So let's say you move to better. That's great. Your new parameter set is accepted and recorded and used as the starting point for the next jump. If you jump and end up in a worse likelihood space, then the parameter set gets accepted or rejected with a probability that's based on how much worse the likelihood is compared to where you started, or rather the end of the previous step. If it's rejected, then you record the previous step again, discard that one, and start jumping from your old place, the same place you were before. The Metropolis Hastings algorithm codifies when to accept or reject. So you initialize with an arbitrary set of parameter values, P, then you calculate the likelihood with that set of parameter values. We'll call that L. So then you make your jump and you're creating another set of parameter values. We'll call it P star, by jumping each parameter a small random distance away from its value for P. And you calculate your new likelihood, L star. Then you calculate your alpha, which is the ratio of your new value to your old value. And you draw a random value R. R is usually bounded on 0 and 1, so that if your likelihood is better than the previous one, it gets accepted. If it's rejected, then there's a certain probability that it could get accepted. There's a random chance of acceptance based on what the value of R is that you drew. And so if your alpha is larger than that R, then you add P star to your posterior chain and it becomes your new P, your new starting point for your next set of jumps. Or you discard P star, you record the previous P yet another time, and then you repeat those steps until your posterior chain has reached a pre-specified length. You do this just for a standard number of times. And in the end, you have a chain. This is the record of your successful steps. So perhaps you start in one area for beta. This is just showing beta, but you would have a similar chain for every parameter that you were jumping. And you can see that it migrates to a particular place. And then ideally, if you've tuned this correctly, then it will explore that space. And at the end of many, many, many more iterations than you see here, you end up with a distribution for beta. Your posterior distribution for beta would look like something like this. Obviously, I didn't put any values here for beta, but this distribution represents the space in which you've converged after discarding the burn-in where it was finding the place it was trying to go. So you run several chains to make sure they all more or less converge to the same location, that they end up with the same posterior distribution. You run some diagnostics. We've got a link to that in your document. There are several standard diagnostics that you can run in R. And that's it. That's MCMC. Good luck.